We have looked at polynomials, just powers of x. This is such a wonky table. Sorry. Yeah, thanks, please. Again, why? Why again?
Happy birthday to you. Happy birthday, dear Mr. Wu. With our glorious math teacher. Happy birthday to you. Hip hip! Hooray! Hip hip! Hooray!
It was, yeah.
All just stopped as you started talking, and then just continued after that.
How am I supposed to teach after that? Anyway. Thank you if you really are. Okay, can I try and do this? It seriously won't take long. We have done polynomial functions, we did trig functions, we did a little bit, we looked at log functions as well, just very briefly. Okay. Shh. Let's knock off, actually, I mean, these are really easy. I probably could have done them before trig functions, but an exponential function, right? Like this, e to the x. Okay. I won't worry too much about other bases because they're not really that interesting. E is where all the action's happening. You differentiate, and what do you get? So this is a fun relationship. So what would you expect the primitive of e to the x to be?
Log E.
Plus a constant. Right. Okay. So you're like, that's boring. All right. Well, let's add in some other stuff. Okay. So e to the 2x. Okay. E to the 2x. Right. Just regular chain rule to differentiate, go in that direction. We're going to multiply by the derivative of the inside. Yeah? Okay. No problem, right? So if I were to anti-differentiate, think about where did it come from, right? Well, instead of multiplying, I hope we're getting the theme by now, right? I'm going to divide, okay? So e to the 2x plus c. Okay? Now, apart from that, there are not all that many interesting variations on this, because a lot of things can be differentiated, okay? Like say, e to the x squared, okay? What is the derivative of that, by the way? 2x e to the x squared, right? But there's no nice, neat thing that thing came from, right? Because you'd have to multiply by it. It'd be a weird thing to get rid of a 2x from the other direction. Okay? Well, you're dividing by 2x. Well, why don't you try it? If I started with this, what would you have? E to the x squared, and you're dividing by 2x. Right? So instead of multiplying by 5. Well, what happens? Yeah, it breaks badly, doesn't it? So you do this. So you're like v u dash. Yeah, that's v u dash minus u v dash, that's 2, all over v squared. Okay, this is not looking good. So I've got 4x squared up there, minus 2 of these. Doesn't look all that great, right? Certainly doesn't look like it's going to get there, does it? You can take out your factor of e to the x squared, but it doesn't make it all that much better. I could take out a 2, well, which is really going to improve things, isn't it? Minus 1 on 2x squared, but big deal, okay? The important thing is that is not this, okay? However, you do get to have some interesting questions like this. Now, I'm going to, rather than show you the answer straight away, I want you to have a work at this, okay? X times e to the x. Okay, so this is a product, okay, it's not chain rule. But you can differentiate this. You wouldn't expect it to be something easy to anti-differentiate, okay? But I want you to spend a minute with it, have a think, see if you could guess what's the primitive function, where it came from, okay? I'll give you a couple minutes to have a think about it. Give me a second. Just
That makes sense. Never mind, I can't guess what it is.
okay. I'm glad I. Yeah. No.
Like trying to keep them off your
Is that also your birthday?
Yes. These trolls, that's high level troll. Almost high as, replumbing a friend's house so that it puts beer out of its taps instead of water. But not quite there, because that needs like trade knowledge and stuff. But
Seriously,
it is.
what happened?
Where?
No, what?
I don't know. It came up on YouTube popular.
I thought you were going to say, well, when I was very young and foolish in university.
Hey dude,
That's
clean
what
up
happened
someone's
when you
wallet
used
and
to
please,
think that
right?
made
You
me
just set it in jelly and we can
That seems legit.
That's so crazy, you told us that last time. So,
They did what?
they clean up someone's keys in their wallet and then set it in jelly. So then you have to eat the jelly.
Oh yeah, they did that to Mr. Biden.
They did what? This time?
But Mr. Bile is someone who would like to do that.
Yeah. But he took a photo of it and he showed it to us.
What?
When he was taking us. Yeah, his science class.
Does anyone have any ideas? Let me have a look. I know what you're saying.
They have to
Oh,
do
well,
that.
write it down so I can look at it.
You could just cut open
You
it.
write down this.
Why would you eat it?
If you don't like jelly.
The great thing about this, by the way, is if you have something, you can test it out and see if it works because you know how to differentiate. So if you think you have a primitive, then it's easy to verify whether you're right or not. I'll give you another 30 seconds and then I'll put you out of your misery.
Mr. Wilson. It's still going.
That's fine. We've got one answer so far, which is right. So I'm interested to see if anyone else can get
Why
it.
is there a line primitive pizza?
Because we don't know what it is.
So, but that's what I'm trying to say.
No, we're doing this one. We're doing this one.
Why not that one?
Because it's trickier to work with. It's trickier to work with. This, on the other hand, even though it doesn't look like a nice, easy thing, you guys, believe it or not, know enough about calculus in general to actually work out what this primitive is.
So we wouldn't need to know that one.
No. You got it? Oh, well done.
Putting it into base.
Okay, I think that was 30 seconds. Close enough. Okay. So here's what I'm going to do, and actually you'll get questions like this. I think I was mentioning it like in period 1 today. Part A of a question might be, take that function and don't find the primitive, but instead find the derivative, which you know quite well how to do, right? So let's do this. So this would be part A. Okay. Do it with me. What's the derivative of this? Okay, yes. I'm going to slow it down just for everyone who didn't catch that. This is product rule, right? Okay. So VU dash, yeah, times 1, plus U V dash. So far, so good. Okay. Now, here's the interesting thing. Okay, I'm going to take this. I'll look at this line, right? And the next question, part B, would be, hence, find the primitive of this thing. Okay. How could you find the primitive from this? Well, the key thing you want to keep in mind is that differentiating, right, to get your derivative, and anti-differentiating really are reverse processes. Okay. So, if I can differentiate both sides of this equation, okay, I should be able to anti-differentiate both sides of this equation. It's just another operation, just like multiplying everything by 5, or squaring, or something like that. Okay. So, remember, this is the thing that I want to anti-differentiate. Yes? Okay. So, if I want to anti-differentiate this, I have to anti-differentiate everything else as well. But I know how to anti-differentiate these two, don't I? You think about it. Let's do this one. It's easy, okay? If the difference between these two lines is I'm anti-differentiating everything, then e to the x turns into what? I'm anti-differentiating, right? It turns into e to the x. What's this thing turn into when I anti-differentiate it? Yeah, well, there's going to be an anti-differentiate and then differentiate, so those two should just cancel each other out, right? It's almost like, just taking the square root, or multiplying by 2, dividing by 2. These are reverse operations, right? So this just turns into this, okay? Now what will be left over is the antiderivative, right? The primitive function of this guy, right? So a primitive of, or this, I'm going to call it capital F, because that's what I'm after, yeah? Whatever it is. It's like, well, if I just want capital F on its own, all I have to do is just rearrange.
I didn't actually find anything.
So does that make sense though? Do you see what I did? Do you see what I did? So the primitive of x e to the x is x e to the x minus e to the x. Plus c, thank you. Okay, I really should have added it in here. Okay, and it's plus c or minus c, it doesn't matter because it's just a constant. Right? It doesn't matter if it's positive or negative. And this should be over here. So that's kind of weird, that as you differentiate, you add this thing, and as you anti-differentiate, you take it away.
Yes.
It's kind of funny,
I
isn't
guessed
it?
it with my twisted logic.
Okay. But these are primitives of exponential functions which you'll be expected to meet. Okay? Yeah. I'm glad we had that conversation. Which step do you want me to?
Yeah. When you
I'm doing this.
So when you anti-differentiate everything,
Yep.
that's supposed to give you x e to x.
I'm anti-differentiating each term independently. Yeah? So I dealt with these two because I know what they will turn into. I didn't know what this would turn into. But I gave it a name, capital F, whatever it is. Okay? But then when I found capital F is over here, and then these two are already dealt with, all I need to do is just rearrange a little bit and get capital F on its own. I just changed the subject. That's all I did. And I can test it out by differentiating. Right? I'm gonna get that minus this because it just turns into itself when I differentiate, which is sure enough what I was expecting.
Does that mean you're going to be needing the c on the other side?
Well, okay, good question. Now, let me go on that. Apparently, I anti-differentiated 3 different things. Yes? So shouldn't I therefore have 3 extra constants for all of these primitives that I've got, right? I should have a constant for this one, I should have a constant for this one, and I should have a constant for this one.
And you add
right?
all the constants together into a giant.
Now here's the thing. If all of these constants, all 3 of them, if all of them are real, okay, then I can just add or subtract them all together. For instance, C1 plus C2 plus C3, or subtract one of them, it wouldn't matter which one, right? And I can just call all of them C, which will itself also be a real number, right? And because none of these are going to change, they're not variables that, flip-flop around in their value, this thing's not going to change either. So I might as well just treat it as just one super constant that I don't have to worry about.
When you rearrange everything for F.
From here? Oh, sorry, I forgot to rewrite it. Yeah, there you go. It won't matter. It won't matter whether it's plus or minus because it's just some constant and I don't care what its value is. So plus or minus, no big deal.